Hello everyone, welcome to today's session. Today we will discuss a couple of most important diagram based questions from the topic total internal reflection as a part of exam boost. Okay, the question number 1, the diagram shows a point source P inside a water container. You can see on the diagram 4 rays A, B, C, D starting from the point source P are shown up to the water surface. It is shown up to the water surface. So this is the diagram given. So what you have to do is show in the diagram the path of this rays. So it is only shown up to the water surface. You have to show the path of this rays after striking the water surface. After striking the water surface, the critical angle for water air surface is 48 degree. It is given. So we have to complete the ray. The ray originating from point P, you can see it is striking the surface normally. As you know that when the ray of light strikes, normally passes undeviated. Alright. So for normal incidence, it passes undeviated. Then what about ray B? So ray B is having an oblique incidence. Okay. So we draw the normal. So the ray B, what will happen on striking the water surface? It will get refract. It will refract and it will bend away from the normal as it is traveling from denser medium to rarer medium. Alright. So that ray, for ray AB, we have completed the emerging ray. Alright. Okay. Now what about ray C? See, look at this ray C. It is striking the water surface at an angle of incidence is equal to 48 degree. It is given the angle of incidence 48 degree, which is equal to the critical angle for water air interface. Okay. So what happens when the angle of incidence is equal to critical angle? When both critical angle and angle of incidence equal, as you know that it will pass, it will refract along the periphery. Alright. So it will refract along the boundary between water and air surface. Now look at that part is completed. Now look at the ray D. Now the ray after, again we are increasing the angle of incidence. Now in the case of ray D, the angle of incidence must be greater than the critical angle. So when the angle of incidence is greater than the critical angle, what will happen? The ray will get totally internally reflected back to the water. So the ray D will suffer total internal reflection as angle of incidence is greater than the critical angle. Alright? Okay. So we have completed the ray diagram for all the rays A, B, C and D. You can see on the board. The second part of the question is name the phenomenon which the rays B and D exhibit. Name the phenomenon the rays B. The ray B is exhibiting plane refraction. For ray B, I can write it is exhibiting the phenomenon of refraction. Okay. For second part, for ray D, I can write it is ray D is exhibiting the phenomenon of total internal reflection. Total internal reflection. Alright. So once you understand the concept of TIR, critical angle, you can easily complete the ray diagrams. Okay. Is it clear? Fine. Moving on to question number 2. Question number 2. The first part is define critical angle. What is critical angle? So all of you must learn the definition of critical angle. You know the definition of critical angle as the angle of incidence in the denser medium corresponding with the angle of refraction in the rarer medium is 90 degree is called a critical angle. All of you know the definition. And the second part of the question you can see on the board. A ray of light passes through a right-angled prism. A right-angled prism 90, 45 degree in the figure. State the angle of incidence at the face AC and BC. At the face AC and BC, what is the angle of incidence? Okay. So a ray of light falling on the surface AB, passing undeviated for normal incidence, striking the surface AC All right. So PQ is the incident ray. All right. So we don't know angle of incidence. With the help of geometry, we have to find out the angle of incidence. So how do you find out the angle of incidence? Just draw a normal. Draw a normal to the point of incidence. This is the normal. Now see, this angle is 90 degree. This is 45 degree. So this angle will be obviously 45 degree. All right. So if this angle is 45 degree for this normal, what is the remaining angle? 90 minus 45. This angle will be 45 degree, which is the angle of incidence at the surface AC. All right. So the angle of incidence is greater than the critical angle, as you know that it is getting totally internally reflected along QR. So the ray QR is getting totally internally reflected and striking the surface BC. So normally, for normal incidence, the angle of incidence here at the surface BC. So at the surface AC, at AC angle of incidence is equal to 45 degree. All right. And at BC angle of incidence is equal to, for normal incident, it is not 90 degree. Remember that it is 0. Angle of incidence is 0. So angle of incidence is 0 for normal incidence. Clear? So you get 2 marks here. 2 subparts, you get 2 marks. Is it clear? Okay, fine. Next, question number 3. As you can see on the board, in the given diagram, a ray of light PQ is incident normally on one face AB of an equilateral glass prism. Equilateral 60 degree prism. What are the angle of incidence of the faces AB and AC? You have to find out the angle of incidence at the face AB and AC. Complete the ray diagram showing its emergence into air after passing through the prism. You have to show the emergent ray also. So let us continue. So with the help of geometry, we can find out the angle of incidence at the surface AB and AC. Okay. So at AB, what is angle of incidence at AB? It is for normal incidence, angle of incidence is always 0. That you know that. So for normal incidence, the ray P passes undeviated and strike the surface at AC. All right. Now we have to find out the angle of incidence at AC, which we don't know. For that, what you do? Just draw a normal to the point of incidence. And with the help of the geometry, we can find out the angle of incidence. This angle being 90, obviously this angle also 90 degree. So 90 plus 60, 150, the remaining angle is 30 degree. If this angle is 30 degree for normal incidence, the remaining angle, what is the remaining angle? 90 minus 30, that is, this is 60 degree, which is the angle of incidence for the surface AC. So at AC, I can write angle of incidence is equal to 60 degree. Okay. So the ray PQP striking the AC at an angle of incidence 60 degree. Angle of incidence is equal to 60 degree, which is greater than the critical angle for glass air, that is 42 degree. So when the angle of incidence is greater than the critical angle, what will happen? It will get totally internally reflected, turning further through an angle of incidence, angle of reflection 60 degree. Okay. So this is the totally internally reflected ray turning through an angle 60 degree and striking the surface BC normally, and for normal incidence it passes undeviated. All right. So for BC, what will be the angle of incidence? Even though it is not asked, for BC it will be angle of incidence will be 0. So the ray diagram is complete. This is the emerging ray going out. All right, without getting deviated. So it is suffering total internal reflection at the surface AC. Is it clear? Fine. Moving on to question number 4. As you can see on the board, a ray of light PQ is incident normally on the hypotenuse of a right angled prism ABC. Ray of PQ is incidenting at the hypotenuse as shown in the diagram. The first task is to copy the diagram and complete the path of ray PQ till it emerges from the prism. So we have to complete the path PQ. Alright, so that is our first task. Let us complete it. A ray of light PQ striking the surface AC normally passes undeviated and striking the surface AB. Okay, what is the angle of incidence? So let me make it more straight, more clear, so I can. Okay. Now this angle will be 90 degree. 90. This angle is 45. So 90, 45. So draw a normal. You can draw a normal here. You have to find out the angle of incidence for the surface AB. So this angle will be obviously 45 degree. 45, 45, 90 plus 90, 180. So the remaining angle, this angle will be 45 degree. So the angle of incidence at the surface AB is 45 degree. So what happens? The angle of incidence is greater than the critical angle. The ray will get totally internally reflected back to the prism and surfacing and striking the surface at BC, as you can see. Again, what is the angle of incidence at BC? We have to find out with the help of geometry. So this angle will be, this angle is 45, angle of reflection 45, and again this angle will be 45. So obviously this angle is also 45. So 90 plus 45 plus 45, total 180. And again this angle of incidence will be 45 at the surface BC. So which is greater than the critical angle. Then what happen? This will get totally internally reflected along and striking the surface AC normally and passes undeviated. Alright. So this angle of reflection will be further 45. So this angle also 90 degree. This is 45 and this is also 45. So all the angles are marked. So we have completed the ray diagram. The first part is over. The second part, what is the second part of the question? What is the value of angle of deviation of the ray? So what is the angle of deviation of PQ? So it is at the surface AB, it is getting deviated through an angle 90 degree, and at the surface BC, it is getting deviated through an angle 90 degrees. So total 90 plus 90, 90 plus 90, an angle of deviation is 180 degree. So the angle of deviation is 180 degree. So through 180 degree, the ray PQ has turned on emerging out of AC. And the third part of the question is name an instrument where the action of this prism is used. So this action of the prism, which turns a ray of light through 180 degree, action, it is mainly used in binocular. It is mainly used in binocular. Okay, this is the action of the prism which is used in binocular to turn the ray of light through 180 degree. Is it clear? Fine. Okay. Moving on to question number 5. You can see, copy the diagram given below and complete the path of light ray till it emerges out of the prism ABC. A ray of light P striking the surface AB, it is given there. It is incomplete and it is an equilateral glass prism, 60-60 or regular prism. So it is a regular prism and a ray of light striking the surface AB. And the critical angle for glass is 40 degree. In your diagram, mark the angles wherever necessary. You have to complete the ray diagram and you have to till the ray of light emerges out of the glass prism with all the angles properly marked. So what do you understand from all this? We have attempted 3-4 questions. What do you understand from all these diagram based questions? Basically the diagram based question remain the same. There is no change. Only thing is, in the board they just twist the way they way of asking the questions. Okay, they just twist the questions and ask. That's all. If you know the concept, you can do it very easily. So ray of light P striking the surface AB. Let us complete the ray diagram. For normal incidence, it passes undeviated and striking the surface AC at an angle of incidence we don't know. With the help of geometry, we can complete it. So obviously this angle is 90 degree. 90 plus 60, it is 150. The remaining angle is 30 degree. Okay, sum of the angle in a triangle is 180 degree. So if this angle is 30 degree for normal incidence, the remaining angle will be Of course, 60 degree, which is the angle of incidence. Alright. So angle of incidence 60 degree, which is angle of incidence is greater than the critical angle of glass, that is 42 degree. So what will happen when the angle of incidence is greater than the critical angle? It will totally internally reflect back to the prism and striking the surface BC. Normally for normal incidence, you know that it passes undeviated. So what is the angle of reflection? Through how much degree it is getting further turn? Through an angle 60 degree. Okay, because angle of incidence is equal to angle of reflection. Alright. So we have completed angle of incidence and angle of reflection. So 60 degree, this will be 90 degree, and this will be the angle 30 degree. Alright. So we have completed the ray diagram with all the angles properly marked. Alright. Clear? Okay. Now moving on to the last question of this session. Question number 6. A ray of light enters a glass slab PQRS, as you can see on the board, and the critical angle for glass air surface is 42 degree. It is given here. Copy this diagram and complete the path of ray till it emerges from the glass slab. Mark the angles in the diagram wherever necessary. So our task is to complete this ray diagram till the ray of light is emerging out of the glass slab, and you have to mark the angles clearly. For that you will be awarded marks. Alright. Okay. So this angle is given 42 degree. Look at this angle. What is this angle? Is it angle of incidence? Usually students get confused and they consider this angle as angle of incidence. No, this is not the angle of incidence. In order to find out the angle of incidence, we will draw a normal to the point of incidence. Okay. So this angle is 90 degree. So 42, and the remaining angle 90 minus 42, this angle will be 48 degree. Okay. So 48 degree, the angle of incidence, the angle between the incident ray and the normal. This is known as glance of angle of incidence. So 42 degrees glance of angle of incidence, which is not angle of incidence. The angle of incidence we are getting it as 48 degree with the help of geometry, and angle of incidence is greater than. So I get the surface PQ, I can write angle of incidence greater than the critical angle for glass 42 degree. So what will happen? It will further get totally internally reflected, okay, along the ray as shown on the diagram. Clear? Are you following it? Okay. Now what is the angle of reflection? Again further it will get turned through an angle 48 degree, because angle of incidence is equal to angle of reflection. Okay. Okay, this angle is 48 degree. So what will this angle? This angle will be 42 degree. Okay. So this angle is 42 degree. This is 90 degree. So what is this angle? This angle will be of course 90. This should be 180. So we should get 48 degree. Okay. So what is the angle of incidence here? Do one thing very simple. Draw a normal. So we'll get a normal here to the point of incidence of this ray. And what is this angle of incidence here? 90 minus 48. Remaining angle we'll get it as 42 degree. So at the surface PS I can write at PS angle of incidence is equal to 42 degree, not 48 degree, angle between normal and the incident ray, which is 42 degree. So angle of incidence is equal to critical angle. At the surface PS angle of incidence 42 degree, which is equal to critical angle. So when the angle of incidence is equal to critical angle, what happens? You know it. The ray will emerge out through the periphery of the surface or the boundary between the glass and the air. So it will emerge out along the boundary between, this is glass and air. Alright. So the ray diagram is completed. So this is the emergent ray, as you can see. Clear? Okay, fine. I hope by this time all of you are expert in the topic TIR and all your doubts are clear. And if you like the videos, please subscribe, like, comment and press the bell button for the further notification videos. That's the wrap up for today. Thank you very much.